Recording. There we go. Are you seeing me or are you seeing my screen now?
You.
Okay. Good to know. I shouldn't poke my nose now. Let's wait 1 more minute, but I'm also seeing if everyone is here. All right. If everyone is ready, I will start. Karen just joined. Who was the last one missing? This is a bit of a trial because I've never recorded something with Blue Jeans before, nor did I give the use Keynote and desktop sharing and such. And in addition, some of you might know some of these things today and others might not know anything. And the way I usually do this is that I do my story, but whenever you have questions, just interrupt me because I don't mind. And then everything is clear immediately for everyone. So please interrupt me if you have any questions, and otherwise I'll get started. So today, what I'm going to talk about is first what Git is. I think it's really important before you start to work with GitLab and before you can even start to understand what GitLab actually is, you should know what Git itself is. And therefore, I'm just going through the basics, the very basics of Git, the concepts, the fundamentals, and then after that, we'll go into GitLab and why you should use GitLab, etc. So I'll start by sharing my screen. I have some slides. All right. Can someone confirm that you can see Keynote and you see a big green thing in the screen?
Yep.
Great. So let's start by the little bit the history of Git. Git is not that old. It's made by Linus Torvalds, who is also the creator of Linux, and Linux comes from Linus and Unix. And he said about himself, I'm an egotistical bastard, and I name all my projects after myself. First Linux and now Git. And apparently Git is English slang for an unpleasant person. So there you go. And the reason he made Git was that he said, I wanted to create the opposite of CVS, which was another source control system that was in use some time ago. Not SVN, that's a more recent one, but CVS. Now, before you understand why Git is interesting and why anyone would use Git, let's talk about what version control is, or actually the different types of version control. So I'm assuming that you have an idea what version control is, but we'll get more into the details of what Git actually does later on. So traditional version control is centralized. So that means that when you're working together on a document, there's a single source of truth. Like there's a central point somewhere on the server. And whenever you want to make any changes to the documents there on that server, you will have to connect to that server, and you are pushing and pulling updates from that server. So whenever Chad wants to do something, he talks to the server, he says, I want to change this document. Chad makes his changes and he sends it back to the central server. And that goes for everyone. And everyone is talking to the same server. Now, that seems like a really nice idea, but it has some downsides. It's hard to manage, and if the server goes down, if the server is on a big load, you can run into trouble. Again, there are many ways to work around this, but this is a problem that persists, and it makes it hard to work. For instance, say that you're in an airplane and you don't have any internet access, you can't really do any work. So then came along the idea of distributed version control, which Git is. In distributed version control, the idea is that every single member in the network, so everyone that is working on all these documents, has their own local copy of everything. In version control, fundamentally you have a history of changes of projects, and we'll get more into that later. And what happens with distributed version control is that everyone has this entire history, everyone has all the documents, and therefore if you want to make any changes, you do not have to talk to anyone. So once Chad has the project that is shared amongst other people, he can do whatever he wants there on his local machine. And no matter what he wants to do, he can just do it locally, and he does not need to talk to anyone else. Only when he explicitly wants to communicate with one of the other parties and exchange information, that's when he actually does that. And this is a little bit the foundation of Git, and the reason why working with Git is so nice. You have distributed version control so that you can do all your work locally, and only when you explicitly need it and explicitly want it, you connect with one of your neighbors. Now, you might have missed a single thing in here, which is the server. So how does it work if you work with many people? Where do they go? Well, the nice thing is that this idea of having it distributed, that extends itself to the server. So in a distributed version control system, so in Git, the server and the Git repository, as it's called, that is on the server, is no different than that on the machine of Chad, of Emily, or Ashley. The only difference being the local changes that they've made. And it's up to them to decide with whom and how and when they exchange which of those changes. So there's no real difference between these different parties, whether they are a server or a person making local changes, it doesn't matter. And to already spoil it for you, in this case, the server could be GitLab. GitLab has many repositories, and if Chad wants to make any changes to one of the repositories on GitLab, he just makes the changes locally, and then later on, whenever he wants, exchanges them with GitLab again. So that's distributed version control. And I said this already, but the really nice thing about distributed version control is that whenever you take the local project, so let's say you don't have the project on your machine, right? You're not a node yet in this network, you're just a person with an empty computer, and you want to start working on a project. So you ask permission from one of the other people, go back to this graph, from either Emily, Ashley, but more likely from the server, you ask permission, or you have permission to pull the project to your machine. In Git, that's called cloning. So you clone the project to your machine. And the trick is with Git is that whenever you clone a project, you have the entire project, all the documents, but also all the history. So every change that anyone has made that was available in the time that you cloned it will be available on your local machine. And this is really important because this allows you to do everything, every kind of operation, all on your local machine without connecting to anyone. And this is also why Git is so interesting for developers. Because you do everything locally, it's all really fast. You can do it in an airplane or wherever you are without internet access. And you can do things really quickly because you're not dependent on having to connect to someone. Are there any questions about this so far?
No, all good here.
Okay. Now, fundamental in using Git is the commit. And it's really important that you understand what a commit is. It's not complex, but it takes you need to accept the concept. A commit, any change in Git that you want to persist in history, is a commit, or it has to become a commit. So that means that if I have a text file and I want to make a change in a text file and I want to commit that change to history, say I want to save this change so that then I can exchange it with others, I have to commit, as it says. And the best way to view this is as a series of points. You see it even more clear here. So here you see every little node being a commit is a certain change set relative to the commit before it. So for instance, if I have a text file and I add a line to it, then if I want to save, if I want to share that change and I want to commit it permanently to the history, I make a commit. And this is basically what a commit looks like in Git, really short. I will show you more in detail later on, but this is what it looks like. It looks like a little piece of letters and numbers, and then there's a message. And that message you set yourself. It's called a commit message. And there you describe whatever the changes that you've been making, or more specifically, the intention you had with making this commit. Are there any questions about the idea of a commit?
What are these numbers and letters represent? So why are they different? What does it mean? Is it an ID?
It's a very good question. So this is called the SHA-1, or some people call it the hash, for instance. And it's a unique reference to a specific commit. And that reference is made based on the contents of the commit and everything that came before it. It works exactly like an ID. It's a unique pointer to this specific commit, and it will never change. So this is a stable thing. And this is a small version, but in fact, it's a much longer string. I can show you in a bit what it looks like, but this is a small version. And this is the only constant. So you know that whenever you refer to this specific number, you will always refer to this specific state of this repository, meaning the changes that were implemented right then, you will always find them under this specific commit. Make sense?
Yes.
Hey, Job, this is Hayden. Correct me if I'm wrong, but maybe you just said that in your last sentence, but the hash represents the state of the whole repository at that particular point in time, or just represents the change?
It is virtually the same, but yes,
Okay.
It's the whole repository in that point in time. So
right.
Yeah, so it builds upon the previous commits, but yes, it's the whole repository in that point in time. So if I change a lot of files between two commits, that one commit will always refer to the exact same state. For instance, if you have a GitLab release, you have release 1 and 2. Release 2 has a specific commit, and no matter how many releases we build, we can always refer to the exact SHA, as we call it, of this commit, and we'll always find the exact same state as it was the moment we released GitLab 2.
Okay, great, thanks. Perhaps just even for my edification, explain why history and particular points in time are so important in software and release engineering.
Sure. Let me go one step further in my explanation, and then I will just dive into GitLab and show you around and explain you. I think there's one concept left to be explained in that, so that
Sure.
you have the right context. So unless there are more questions, I will continue. So the commits, they follow each other. They are sequentially followed in time, and of course they also log things like when they were made and by whom they were made. Typically, or actually always, commits live on a branch, and a branch you should see as a timeline. So this is like the main timeline, the one that we live in right now. And the main timeline by default is called master. It's called the master branch. And you will hear people talking about master this, master that. That's because that's the one timeline that everyone shares. It's just a name master, and it's just the default name, so it could be anything else. But this is usually the one that everyone eventually points to. I'll talk about other branches in coming, but you should understand this is the main timeline. So if you're going to do any kind of work on a repository, you're going to take the latest point in time. So it looks like this. You are here at this point in time, which is the point after the latest commit or master. And this is usually where you start working. So what I'm going to do now is I'm going to open Chrome, and I'm going to show you GitLab and show you how it looks there, and give you an idea of how it actually looks and works. Let's see, I have to. So now you should be able to see my Chrome window. Is that correct?
Got it.
All right. So what you're looking at now is a project in GitLab, and you're looking at the GitLab project. So this is where we actually develop GitLab. And this is on our development server. Let's go to the commits, which is self-explanatory. So this is what actual commits in GitLab and commits of the GitLab project look like. So you see there's an author, there's a nice little picture, and you see the commit message as I described before. And GitLab does a smart thing where it orders them and it gives you some extra information about when they make it. But this is basically how it looks. You also see here a reference to master, which is to say that I'm now looking at the commits on the master branch.
So, Job, can I just ask a quick question? You know, you said GitLab did do that. Is that, can you just distinguish if as you're going through where GitLab varies from GitHub? If we do, is that something that GitHub do as well, or not?
Yeah. So everything I will explain today, both GitHub, GitLab, Bitbucket, and Atlassian Stash will all do this. This is all basics. So let's look at a specific commit. For instance, this one says fix navigation link for dashboard made by Camille. And I click on it, and then I can see what actually happened. So this is what a commit entails. You see here the commit SHA that I told you about, and this is the full length. This is the whole piece of information. You see that it was made by Camille 4 hours ago, and this is all information that is also present in the commit. It also says who the parent is, and the parent is of course another commit, as you just saw on the master branch, and you see here in which branch it lives. Here we see the commit message, and the commit message should usually describe the intention of the commit. Sometimes it's something simple. But now let's get to the interesting part. Down here you see a little bit of...
Question.
Sure, go ahead.
Did we just see that Camille is not using his camille@gitlab.com address to make these commits?
So when you are committing, it's allowed to use any email or any reference to your person as you see fit. You don't have to use your company. That has the advantage that if you make open source contributions like Camille does, they persist independent of where you work and what you do. It also has to do with what you've been doing. Most people use the same email address since the first day they started using Git, which is also nice because then you have an easy collection of all your work. You will also see that I also don't use my GitLab email. So this is the most important part. You see a bit of code here, and this is actually a bit of code of GitLab. And GitLab automatically truncated the file, but it is actually this file that Camille has edited. And in here you see some lines in red and some lines in green. And what this means is quite simply, the red lines were removed and the green lines were added. Depending on what kind of change you do, sometimes it highlights a specific change, because if you look closely here, most of it is the same, it's just that this part specifically changed. And this is what a commit is. It's simply a change in relation to its parent on one or multiple files. In this case, it's a single file. And we see that Camille made this specific change here. So I told you that a commit represents a change, and we see that here. But I also told you that the commit goes for the whole project. So it sets a state for the entire project. And to show you that, I can click Browse Code. So what you're looking at now is the entire GitLab project, so GitLab CE. And GitLab CE is basically a bunch of files and some directories with more files in them. And by clicking on the commit, by saying Browse Files, I am now looking at the repository at the exact time right after Camille made his change. So I'm now looking at a specific point in time. So I will share my entire screen so I can quickly switch between Keynote and Chrome. So let's say we are now on the branch somewhere, and we are now looking at one specific commit. So I highlighted a certain commit, and we're now looking at this point in time. So all the files are exactly as they were when Camille made this change. So the nice thing is that GitLab allows me, and this is one of the reasons why it's nice to use GitLab, to quickly jump to another point in time and say, I want to look at a specific version or at the master branch. So Hayden, you asked, why is it interesting to use Git for developers and use Git at all? Now imagine that we have a bug in GitLab.
I'm sorry, so you're saying that, like GitHub, for example, you can't do that?
Yes, you can do this as well in GitHub.
Okay.
Yes. I think the advantage of GitLab is that traditionally Git lives on your command line. So you type out all your commands. So for instance, the list of commits that I showed you just now, if I want to do that on my command line, it looks like this. That's not really intuitive and nothing really links to each other. And for instance, if I want to look to the state of a repository in a certain time, I have to copy this, I have to do a command, and then I have to look at the files themselves. That doesn't work as easy as GitLab. You don't get to see much information, and it's impossible to use unless you know really well how to use the command line. So to answer Hayden's question, why is it interesting to use Git? There's many reasons, and the two most important ones are, one, that you can collaborate effectively, and that's where GitLab itself helps even more. But two, because you have an entire history, you can easily change things that were changed in the past. You can hunt down bugs. You can hunt down changes that were made and why they were made. So let's say we're releasing GitLab 8 in a few days and something is broken. What happens is that we look in the logs of GitLab and we see that a certain thing on a certain line of a certain file, GitLab stops working. Now all we have to do is go to that specific file. Let's go to a random file here. Let's take the README. Go, README.
And by the way, I just want to add that these are kind of version control fundamentals. It's not sort of unique to Git. This is why software development is critical to having version control, so you can roll back versions of software essentially and find bugs within two different versions of the software.
Yeah, that's correct. So let's say we find a certain line broke, and we know that the line happened in a certain file. I can just go to any file, whichever file I want. I can click on the history, and I will see exactly when changes were made to this specific file. So if there's a bug in GitLab 8.0 and we know where it happened, we can quickly check down what the change was that was made. So now I'm looking at only the changes that were made in the README. I can see that this person made a change, Dimitri made a change, Arun made a change recently. And we can quickly track down when the change was made. And because we have the merge, we have the commit message, we know why the change was made. And with the power of Git, we can even revert the change. So there's a command in Git that allows you to just revert that specific change and nothing else to how it was before the bug was introduced. So this makes it really easy to manage many files and many changes and still find what was changed at what point in time, for which reason, by whom, and we can even revert those changes selectively. And there's a nice feature in Git for this specifically. It's called blame. And it's called blame because it allows you to blame someone for a certain thing breaking. And it allows you to see this. So here we are looking at the README, which is a markdown file, which you will all have to work with one day. And here you see who made each change for each specific line. So we see that Pizza made a change on this line, Dimitri made a change on this line, etc., etc. This is another tool you can use to track down why a certain change was made to a certain line. Any other questions about this so far? Good.
Job, I think you're probably going to discuss this, but yeah, how do commits become accepted in a master branch?
I'm going into that next, Ernst, so yes. Okay, so we spoke about having a branch, and on this all the commits are stacked. And you can go to any commit if you want, it's just like Back to the Future. In your command line, you call this checkout. We'll get into this one day. I'll teach you all how to use the command line. If you make any change,
teach us how to do time travel.
Yes. That I just showed you time travel in GitLab, and this is all you need to do. So if you make any change, you make a commit, and it will automatically get this SHA assigned to it based on the contents of the repository. That's really nice, but if everyone would be making changes on the same branch, that would cause problems, because remember that everything is local. So if Chad makes a change on top of this commit and does not exchange it with anyone, and I make a change on this commit and do not exchange it with anyone, and we decide we want to sync up and we want to exchange the things that we've been changing, how do we know where what goes? We both built on the same point of history, and we both made a commit here. That's going to create a conflict. And that's actually what it's called in Git. It's called a Git conflict. That's what happens when two changes were made in the same point in time. And that's impossible. So the solution for this is called a branch. Just like the master branch, you can decide to create other branches. And what you do with a branch is, from the point in time that you're interested in branching off, so to say, and usually that is the latest point in time, right? So that is this little orange commit here. From that point in time, you create your own branch and you work as normal. So you make changes, you create a commit. You make changes, you create a commit. And you do that for a while. I have to scroll on in my file. By the way, the Git commands look like this. And then at one point, you want to merge it back. So what you do is you branch off, you create your own branch that you give a name that you want. For instance, if you're working on a feature, you call it feature X. And then you want to merge it back into the master branch. And once you merge it back, and I'll explain more in detail how and what and why, it will appear in the history of everyone else and it will be shareable. Okay, that may sound really abstract and doesn't make any sense yet, but I will show you now in GitLab how that works. So the nice thing is that you're working in a project, and once you've created the branch, you are able to make changes as you want. But not only that, because you're working in a separate branch, go back here, I can just share this branch with everyone else. It has a unique identifier, a name that I gave it, a branch name. For instance, feature X, like I said before. So the branch has a specific name, and because of that specific name, and everyone just uses master, it doesn't interfere with anyone's work. So the changes that I made and the changes that Chad made, they will not interfere because they are on separate branches. At the same time, the master branch can just continue because I'm here separate and it will not get any influence from changes anywhere else. So you have to imagine it, it's like two parallel timelines. You traveled back into the past, and now with Git you don't have to worry about meeting yourself because it's completely separate from each other. You took the lottery numbers back with you, for instance, and now you're trying to actually win the lottery with that. So what you end up doing is, once you're happy with the changes that you've made, so I'm happy with all the changes that I've been making here in this specific branch, you push them to GitLab. So you share them with GitLab. And the command is actually called push in Git. You actually type Git Push, and that's why I'm saying push. So you push them to GitLab. And what will happen now is the nicest thing and the most important part of this whole thing. And this is why you should be using GitLab. Because what you can do in GitLab is you can create a merge request. I'm going to show you one, what it looks like and why you should do it. A merge request is a request to someone or a bunch of people to merge the changes that you've been making in this branch to the side, to merge them back into the main branch, so that you come to this point where your changes are accessible to anyone and they are merged into the master branch. So the only thing you do after pushing the branch in GitLab is you press the button to create a merge request and get this little window. Nothing has been merged yet, but the person, in this case it was Karen, that made a change and she assigned it to me. The person that you assign it to, and anyone else with access to the project, is now able to see the changes that you've been making and that you want to merge into the master branch. So in this case, we're seeing that Karen made a branch called global key, and she wants to merge it into master. And the changes that she made, they are visible here. She added 2 lines to a certain file. Now, I told you that at the same time, master will still move on and changes can be made to master. So what Git, and in turn GitLab, does is it looks at the difference between the branch that Karen made and master. And it specifically looks at the changes that she's made from the point in time in comparison to master. So there might be other changes made since the moment that she branched off, but Git is smart enough to know that it will only look at the changes that Karen specifically made from that point in time. Does this make sense so far?
One question on this, Job. So in this case, for example, the CI build passed, which I assume means it's been tested and there's not going to be conflicts if this is merged. But that was, for when she did that CI build. In the meantime, the master may have changed again. So how do you continue? How do you know that it hasn't become conflicted in the meantime?
So whether it's conflicted or not is something that we check in real time. So every time you want to accept it, Git and GitLab will check whether it's actually conflicting. So that's not an issue. About the CI, I will get it. Well, it is the next thing I was going to talk about. We only test for this specific commit, meaning we test this branch, so the state of history in this branch, and we take that. So irrespective of the changes in master, we're testing this. So this will stay valid forever. Chad, you had a question.
I did. Going back to your example where multiple people are making changes at the same time. So let's say it's myself, Ashley, and Emily. So we all 3 basically will create our own branch.
Yes.
Okay. And then once we complete that branch and we merge it, so let's just say all 3 of us merge it and we put in a commit request.
Yes.
Can you speak through that kind of scenario? Like, are all 3 of those going to be looked at? What's the sequence, or is it timestamp? Stuff of that nature. Yeah.
So you all 3 made a change, and you all 3 pushed your branches to GitLab. This can all happen asynchronously, doesn't matter. You all 3 make a merge request. If you've changed the exact same line based on the exact same history, whomever's merge request gets merged first will make the other 2 conflicting. However, that scenario is extremely unlikely because usually there's only one person editing a specific line. For all other scenarios, Git is smart enough to know to see which change you made, so which line you made, what kind of change that was, and depending on your history, it will automatically check whether it can merge that into the current state of master, irrespective of changes that other people have made or are going to make. So in your example, Chad, if you've not changed the exact same line, it will look exactly like this, and you will press and you can merge them asynchronously in any order. Because you've changed different files, because you've changed different lines, Git is smart enough to realize that, oh, they have the same history, so they do not have that part that changed. For instance, Ashley makes a merge request. We merge that first. It changes something in a file, but in your history chat, you do not have that change in the file yet. However, because you didn't change that file, Git will simply ignore it, and it will assume, okay, you didn't have that history, but you're not making any changes there either, so it doesn't matter. I can just continue merging whatever you have there. And Git is, the way Git does it is quite simple, and there's a few algorithms for it, but the trick is that Git is always trying to play dumb. So if there's any chance that there's a conflict, it will not do magic, and it will just report there's a conflict. In practice, this happens, well, almost never. Almost never, only if you're working on the same files continuously with many, many changes. Did that answer your question?
Yes, and even more so. So great clarification. Thank you.
All right. This is not easy for me to explain all these things. I'm always worried that you get lost in my long stories with many specific words. So really don't worry about interrupting me if you have any questions. All right, so we have Karen. She created a merge request because she made this little change in this specific file, and she wants to merge it into master. And she wants to merge it into master because the master branch is the one that we built GitLab from. And in this case, she changed something in the documentation. And this is also what we use to build the documentation. So the moment this is merged, this will be available to the public. But for now, it's just her branch. So what she did, she created a merge request and she assigned it to me. And this is the magic of GitLab. The merge request, that is something that doesn't come with Git, but it's something that we bring to the table as GitLab. Of course, GitHub has the same. They call it a pull request. And it allows me and anyone else to check the changes that she's made and to see whether these are changes that we actually want in master. In fact, what you can do in GitLab is we can prevent Karen from putting any commits on master unless it's through a merge request. And she's not able to merge this herself. She doesn't have the permission. So what happens next is that upon creating this and assigning it to me, I get an email to review this. I see what she wrote here. And next, what I do is I look at the commits, see what she's been doing. She made 2 commits. And I look at the changes. And the changes represent the changes of course, the latest commit. And what I can do now is I can go into the changes that she's made. And on a line that I have something to say about, I can add a comment. And actually, if we turn this on, we can see that I already put a comment here. And I can put a comment here saying whatever I want. And the nice thing is that she can then go into, she will get a notification about this. She will get an email. And now Karen has the option that if I suggested, and I did suggest some changes, she can now simply create another commit on the same branch, push it again to GitLab, and GitLab will automatically update this merge request. In the end, what will happen is that, because I will get an update, I'll be happy with the changes that she's made, and I will click accept merge request, and it will get merged into master. And from that moment on, the changes that she's made, in this case, deploy keys are being added this line, they will be available for anyone in a master branch. Meaning that if you start working from that moment on from the master branch, you will have that changed as well in your project. And there will be a new commit on top of master. Now, considering she created a merge request, and Ernst already mentioned this, we have the opportunity at this point to not only have it reviewed by me, but also have it reviewed automatically. So what happened in this case is that GitLab CI, it automatically picked up the code, the latest commit that she made, the entire project, and it ran all the tests of GitLab, including the changes that she's made. This is nice because in GitLab, for instance, we have a test suite that automatically tests features and certain parts of the project that as a human you can't always oversee by seeing, oh, we changed this here, so this will break this and this and that. And by now that's in the many thousands of tests that we have. So what happens whenever someone creates a merge request is that GitLab CI picks up the code from this specific commit, runs all the tests, and if they pass or fail, it will report back here. So golden rule is that all your tests should have passed. We wrote it down here, I think. So you can only bring change to the timeline, to the master branch, when it's tested and reviewed. And this is basically the main point of using GitLab. On one hand, it allows you to work together really easily. So it's much easier to merge changes and bring changes from many people together. You know that there's a central point. We do not lose the distributed nature of Git, but we know that there's a central point to which everyone eventually will point. And at the same time, it allows us to easily test and review any code before it gets to the main timeline, before it gets merged into the master branch. Because if anything is on the master branch, it will ship to all of our customers and it will ship to everyone else. So it's very important that this happens once. So after clicking the accept merge request button, and I can remove the source branch, meaning that I can remove the branch that we have here after we used it, which is a good idea because we'll not use it ever again. Master will be updated. The commits will be placed in the time that they were made. So if I made this commit on Tuesday, someone made another commit on Wednesday on master that did something completely different, and all my other commits were made today, this is what the timeline will look like. That's a smart way that Git handles times of commits. And that's the very foundation of how you work with Git, how you work with GitLab. Are there any questions about this or any things you would like to have clarified? Because I think this is a nice cutoff for today, because this is the very foundation.
Just one question on the CI build.
Mm-hmm.
My understanding was that it is something that is right now specific to GitLab, that there is this close integration to GitLab CI, but other Git tools, if you will, also have their own CI plugin tools or whatever the proper terminology is. Can you talk a little bit more about that? Sort of, is this something specific to GitLab? Yes or no?
Sure. So there are many CI tools, continuous integration tools. Some are free, some are paid. All of them, or pretty much all of them, can work with any of our competitors' tools and our own tools. The only thing they have to do is they have to be able to pick up a commit and take all the code from that point in time and then do the stuff that they do in the CI. So that in itself is not unique. What is unique is that GitLab and GitLab CI are closely integrated so that we see actually the status of the CI here, rather than that we have to go to www.ci.gitlab.com and then search your project, etc. Now this is unique for GitLab CI and GitLab, but our competitors all have different integrations that also allow this. So for instance, GitHub integrates really well with a large number of continuous integration tools, including the most popular being Preface CI and CodeShip. And they all report in a similar way. It's not exactly the same, but it looks basically the same way. Also in their merge requests. GitLab CI does not work with any of those tools. That is on purpose because we're integrating it into a single tool. Yeah, I think that answers your question, Ernst, doesn't it?
Yes, it does.
And we just integrated CI, which you heard about. I'm now checking out. Ah, look at that. So I can just click on the build status and I will immediately see here what happened. So in this case, it picked up this specific commit. You see it here, made by Karen at this specific time. And we set up a continuous integration for GitLab to run a bunch of different tasks. You see here the different tasks that it runs. And the nice thing is that GitLab CI can run them in parallel and do different things. It tests, for instance, for code. It tests for certain features, etc. Any other questions? No questions. You must all be really, really good. Next week we're gonna do a little exam.
Well, really overwhelmed.
Ask me anything. If it's it doesn't matter if it's a simple question or.
Are we going to get enough rain in California this year?
It's very too broad of a question.
So yeah, with GitLab or Git, and again, this is my novice education right now. Are there any limitations, bandwidth, anything that would slow this down, or we hit capacity?
I think I turned off my screen sharing. There I go. Yes, there's one thing that Git is extremely bad at, and that is managing large files, and namely large binaries. So it's made to work with code. Code is just a bunch of text files, and it does it perfectly and without any problem. However, once you work with binaries, meaning anything that does not look like a text document, Git will not work really friendly with it. If it's small, it doesn't matter because it tries to handle it like text file, which doesn't really work. But once the files are starting to get bigger, think about images, or even worse, images of operating systems or disk images, which are many hundreds of megabytes big, Git can't really handle that. And that's fundamental to Git. There's nothing to do with GitLab. And there have been solutions for that. One being Git NX, which we are the only one to integrate. So none of our competitors integrate with Git NX. And what Git NX does is it just puts a reference in your repository to the big file rather than the actual big file. Another solution is Git LFS, which is now being developed by GitHub with the support of Atlassian, and that's something we will integrate as well in the future, because that's the future where it works the same way as Git NX, but it's easier to use. You can just put a big file in your repository, and Git will automatically say, oh, this is a big file, I'm going to put it somewhere else, rather than putting the whole file in your repository.
And then, thank you for that. I dropped off, but I got most of that. In terms of, in your example, you showed multiple people on a server. Any limitations, concerns, challenges when we're dealing with multiple servers?
So not really.
Okay.
GitLab scales incredibly well. You can just, so what you're seeing is you're seeing GitLab, the app, but it actually runs on multiple servers. It doesn't really matter. GitLab is made for that, and we're working on nice solutions for that. If you're working with many, many people, that's fine as well, because we organized GitLab in such a way that it's quite easy to organize large amounts of people and people to organize themselves. We'll get into this in a later session, but there are no real problems with handling many users besides typical technical problems. If you have many users, you need a bigger system to run it on, and you need to be highly available or have many, many servers underlying GitLab. But in Git itself, on the way the workflows work, no, it doesn't really matter, and it scales really well. If you have a project that is extremely big, you will have many developers on it. But because the project is so big, it shouldn't be a problem, and the other way around works as well.
Anyone else?
Yeah, Job, I was just going to throw in, and again, correct me if I'm wrong, but my understanding is that Git is it the best at handling really large code bases. Splitting them up into multiple repositories is kind of a good solution, but then building out of all those repositories and propagating changes amongst the repos just makes it a little bit harder to manage. Is that kind of a true statement?
Yeah, I think that you could say that. So we used to test a lot with the Linux repository, which is the whole core of Linux, which is really big, which works fine with Git. If you have older projects that do not use like modern tooling and such, and they were built on SVN repositories, for instance, they had massive code bases, many, many times larger than any of the typical Git projects. What they end up doing when they migrate from SVN to Git is that they split it up in multiple repositories. So when you do that, when you go from that one large monolith to many smaller repositories, you have to find a way of putting all those things together. That is a challenge. And that's the way you want to keep repositories relatively small in Git. Relatively can still be huge, but you want to keep them relatively small. If you have projects that use many Git repositories, yeah, that happens with some projects. For instance, if you make video games, you're likely to have multiple repositories, so you can have art separate, you can have other things separate. I don't know if it's more challenging or not. I think it's challenging for the companies that migrate from SVN or the other systems. What you see now is that there's a move from extremely large companies like Google and Facebook to have a single code base. And they do that in Mercurial, which is a competitor of Git. It's much less popular. It's a little bit less intuitive to use, but it basically does the same. But 99% of the cases, 99% of the companies use Git, move to Git, and for almost all cases, you can use Git just fine. It just depends a little bit on the workflow that you set up.
Yeah, I think my understanding is modern, code-based architectures have changed a little bit, where it's a bit more modularized anyway, in terms of microservices and linking modules together using APIs, things like that. I think that's played into the hands of Git. Is that right?
I don't know if that's the reason why Git is popular. I think the reason Git is popular is because it's lightweight, easy to use, and really fast. It helps that you can do that. There's also tools in Git to bind together many repositories. You have things like submodules. I don't know. I wouldn't say that's the reason that Git is popular, and I wouldn't say that will make it more popular. I think that's just the future, because it makes it easier to collaborate on things by having many separate parts.
Yeah, I was just saying that was kind of fortunate for Git that sort of architecture came about, because it kind of works, plays in the hands of Git, if you know what I'm saying.
Yeah.
Okay.
Any other questions?
Yob, you just kind of touched on it, but I think a good question, especially for salespeople, is if somebody asks, why would I move to Git from Subversion or something like that? Like what? I know you just kind of touched on it a little bit, but maybe just a quick summary of why people in general are moving to Git more.
Well, people are moving to Git because developers love it. That's the first. Developers are more productive because it's lightweight. Everything is local and it's really fast. It allows you to really quickly iterate. And because you can quickly iterate and you're not forced to, but you're encouraged to make many small changes quickly and have them reviewed quickly, you can create modern workflows that employ things like CI tools, and more importantly, a nice review process, which GitLab allows. And by having and doing those things, your code quality will go up, the productivity will go up, your iteration speed will go up, and you can do much more complex things with more people, because you're not fighting with any conflicts. When you make really big changes, like you used to do traditionally with SVN, for instance, and then once in a while merge them back in, you're fighting with conflicts with other people that make big changes. You're fighting with a really long review process and a really complex CI process, because there's one big change, but many. When you make small changes, much easier to review, much easier to iterate. Everyone is more productive and happy.
Awesome, thanks.
Hey, just on that note, Josh, I find that especially up to this point, maybe it'll change when we do more outbound, but most times companies have come to their conclusion that, we have to support Git. We have to support some sort of Git management tool to offer our, developer community, and it's a matter of which one. That's kind of where most of the leads are at by the time they reach us. Is we've been invited to the table to participate in the evaluation. They're moving off Subversion. They know they want to go to Git. What are they going to use? But I suppose if we do more outbound and we get people earlier on in that whole process, there might be a little bit of convincing that we need to do to get them to move off those old centralized tools.
Yeah, I think if you ask any developer, they will have used Git and they will prefer Git over SVN. Anything else?
Yeah, it's only the old crusty programmers that don't want to change. They dig their heels in. They don't want to learn a new tool. They're like, I'm happy with Subversion.
So, Yob, thank you so much for the time and then everything you put into this presentation. I think it's a great start. And for everybody on this call, as Yob mentioned, is let him know, let us know what subjects you'd like to learn more about. I think going forward, one of the definite things I think Yob's going to be doing is on the releases is taking a training session either before or right after that in terms of what was released. But anything else around Git, around specific GitLab, let us know. This is for us. So your suggestions are more than welcome.
Awesome. Thanks, Chad.
Thanks, Yob. And then if you can just share this with me so we can just kind of push this or publish this somewhere, that'd be great. Thank you all.
Thanks very much, Yob. Really, really useful. Thank you.
Cheers.
Appreciate it, Yob.
Yeah, thanks as always, Yob.
Thanks, Yob.